Ah, welcome back from break. I hope you were able to enjoy break, however it was for you. I know some people don't really even get breaks right now, and I know it's just kind of an odd time, but we have about 7 weeks to go. And in these 7 weeks, I do want to make sure that you still get exposed to some of the most important physics concepts of the year. Obviously, we're not going to do as much work as we had initially thought, but I'm going to give you some of these things, and hopefully you can find some of them interesting. We're going to do some more simulations, a little bit more work, and a little bit more math, and I'm going to be here to help you every step of the way until graduation. Our topic today is energy. You probably may not remember, but before we went on break, we were talking about work and power. This is all connected. The photo in the background is of a roller coaster. Roller coasters are really a great example of how energy works. This is a wooden roller coaster in a place called Cedar Point, Ohio. And we're going to get way more into roller coasters later, but I'm just kind of curious. If you've ever been on a roller coaster, I want you to know that wooden roller coasters are far better than the metal roller coasters. The metal roller coasters are just too safe. There's too many safety features on them. If you really look at this, if you want to see a good roller coaster, what happens is you get in a wooden roller coaster, you get into the car, they say a bunch of things, and then you go. And you roll down a very small little incline until you hit the bottom of the hill that's got a chain on it. And that chain's going click, 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 click. And that chain is doing work to the roller coaster. And it's lifting it up into the air until it gets right here. And once that roller coaster is off the chain, the only thing acting on it is gravity. Nothing else. It falls. If there is an emergency and they're like, we have to stop the roller coaster, nothing you can do. You just have to wait for it to finish at that point. You are truly putting your whole life into physics' hands, and that's why wooden roller coasters are way better than metal. Metal roller coasters have those safety features. You've never seen a picture of a wooden roller coaster getting stuck up and down and they have to bring out the fire trucks and get people down. That always happens on metal roller coasters, not the wooden roller coasters. So what is energy? Energy is the ability to do work. If you have energy, you can do work. I don't really remember what work is, Bizzuto. Work is essentially pushing a force a distance, essentially movement. Energy, work are all connected to movement. If you are low energy, you don't feel like moving. If you are high energy, you are bouncing off the walls, you are moving a lot. Energy is connected to movement. And I want you to know that both energy and work are measured in joules. Energy and work are measured in joules. I also want you to know that, yes, energy is connected to movement, and then doing more work on an object gives it more energy. What do you mean by that? So like, if I lift something into the air, or if I push it hard and it gets going faster, I've increased the object's movement. If you're walking down the hallway and you see your little brother and you push him, you've given him some energy. You've done work to him, and you've given him energy, because now he's moving when he previously wasn't. By the way, joules is the unit for energy that we're going to use, and they use all over the world. But the unit for energy that we use in the United States, because the United States is backwards, so they call it a calorie. I don't want to get too far into this, but if you ever look at a food label, it says how many calories in it. That's the energy in a food. If you ever go abroad, you go to any other country that is not the United States or not England, and you look on a food wrapper, a food label, when you go ahead and see, it won't have calories. It'll actually have a number, it'll say kJ for kilojoules. It'll actually measure the energy in the food as kilojoules. That's just a little side fact I thought some of you might want to know. But if you ever understand, if you ever leave this country, energy is measured in joules. We in the United States measure energy in calories. And again, calories is the part of food where you get your energy from. That's biology. I don't want to review that. So there are different types of energy. And today, I want to focus on two of them. The first type of energy I want to focus on is called potential energy. Potential energy. This is called the energy of location. Okay. I don't understand how an object's location could determine its energy. I said energy is connected to movement, right? So look around you right now. If you have a book next to you, your phone next to you, it's on the ground. It has no potential to fall. But if you pick it up and you lift it above your head, now that object has potential to fall. And falling is movement. So if you lift something higher in the air, it has more potential to fall. It has more energy. So the higher up something off the ground is, the more potential it has to fall and to do work. So if you lift the book up, what would happen was you lift over your head, you drop it, the book would fall, it hits your head, and the book would do work to your head. It would move your head a distance. So there is going to be math to this. Yes! This is an equation, and for those of you who do not take notes on these PowerPoints, I recommend at least writing this down. Potential energy. And by the way, potential energy is measured in joules. All energy is measured in joules. Equals mass in kilograms. Gravity is going to be 10. Wait, Pizzuto, I thought gravity was negative 10. For the energy equations, we use positive 10. Use positive 10. And the reason is because energy doesn't have a direction. The negative just meant down. But energy does not have a direction, so we're not going to use positives or negatives. It's just going to be signless. And then the height is measured in meters. So it says, what is the potential energy of a 3-kilogram rock sitting 4 meters high? Potential energy is going to be 3 kilograms, 10 meters per second squared, gravity, meters per second squared, not important. 4 meters. We multiply them all straight across. 3 times 10 is 30. 30 times 4 is 120 joules. That's it. You just multiply them straight across. But you have to know what the gravity is. You have to know that gravity is 10. Okay, so let's just try a sample problem, because your homework is going to be to do potential energy math. So let's make sure we know how to do this. So what is the potential energy? Okay, potential energy, PE, equals mgh. PE equals 28 is the mass, kg is the mass. Gravity is always going to be 10. Gravity on Earth is 10. And the height is going to be the meters. That's it. That's it. It's actually that easy. So the thing is, we got to pay attention to these units. Meters is going to be height. Height, how high are you? It's a distance. And then kg is going to be the mass. So height is meters. Kg is mass. Okay. So when I just type all that in, I'm going to type 28 times 10 times 15 in my calculator. And when I do that, I get 4,200 joules. How did I know it was joules? Potential energy, all energy is in joules. That's it. Easy. We're going to spend a lot of time on energy. We're going to get into concepts in math. Today's a math day. Concepts are coming, but I want to make sure we can do this math. But I have a question for you. What's the potential energy of something that's on the ground? Well, if you're on the ground, you have no height. And if you have no height, if the height is 0, if this is 0, 0 times anything is 0. The second type of energy that we're going to get into today is called kinetic energy. And when you go ahead and look at this word kinetic, okay, kinetic has to do with motion. So we had the kinematic equations, those are the energies of motion, the equations of motion. If you are into superheroes and if you are telekinetic, you can move things with your mind. Tele means mind, kinetic means motion, mind, emotion. So kinetic energy is the energy of motion. And I think this one's a little bit easier to understand. The faster an object moves, the more energy it has. I think that's self-explanatory. It takes more energy to go faster. Okay? And it takes more work to go faster too. So here is the kinetic energy equation. This is the second equation that we're going to learn today. We're only learning 2 equations today. And I want to make sure that we have a concept of what this is. So KE is kinetic energy equals 1/2 mass times velocity. So kinetic energy is measured in joules. All energy is measured in joules. Mass is measured in kilograms. Velocity is measured in meters per second. So, what is the kinetic energy of a 1,000 kilogram car moving 3 meters per second? Let's plug it into the equation. Let's see what we get. 1,000 kg is the mass. The velocity is 3. So if you can't see this math, I know I did skip some steps in this math, but we'll do a practice problem too. 3 times 3 is 9. We don't care about the unit anymore. 3 times 3 is 9 because we have to square it. 9 times 1,000 is 9,000. Half of 9,000 is 4,500 joules. We're going to see how that's going to work out in the next one. But we've seen equations like this before. It's actually similar to the D equals 1/2 AT squared in terms of the setup and the math. It's really nothing different than that. We've done this before. But the kinetic energy equation. So what is the kinetic energy of a 20 kilogram steel ball rolling 4 meters per second? So let's go ahead and do this one out together. Kinetic energy equals 1/2 mv squared. Mass is kilograms. Mass is kilograms. We're looking for the kinetic energy. So Ke equals 1/2. The mass is 20. The velocity is 4. Meters per second is 4 squared. Okay. So all I did was sub in the mass and the velocity. That's all I did. Now I have to do order of operations. I have to do PEMDAS. Cannot forget that. So what I'm going to do is I'm going to do 4 times 4 is 16. 1/2, 20, 16. Awesome. So now what you can do is, it doesn't matter the order in which you do this. You just multiply it straight across. Half of 20 is 10. Half of 20 is 10. And then 10 times 16 is going to be 160. So the kinetic energy here is 160 joules. That's it. All energy is joules. Just plugging in the equations and solving. Questions, thoughts, problems, comments, concerns? I'm now going to have office hours every day from 12:30 to 1:30. If you want to just stop by, say hi, ask for help, questions, I'd love to help you out. I know it's going to be an odd 7 weeks, but please, we have this, guys. We're going to do this work. We want to get to graduation. That's the goal. So let me know how I can best help you to do that. I wish you the best, and I hope to see you all around, and stay safe, because that is the most important thing. I will see you guys next time.